Welcome to my channel. Today I'm going to teach you how to do synthetic division along with how to do the factor theorem. Alright, getting right into it. What synthetic division is, it's a process for dividing a polynomial by a binomial in the form x minus a. You've likely already seen this in quadratics if you've done that unit, but what it is you're pretty much just changing the sign. For example, you might have a question that's like x plus 2, what you're really going to be dividing it by is negative 2. Alright, just jumping right in, let's start with 2x to the power of 3. We'll go plus 3x squared minus 4x plus 15. First thing you're going to do is build this model right here. This is what we're going to use to divide it. It looks similar to that of long division, just maybe flipped upside down and mirrored, but close enough. And we're also going to be dividing this by, we'll go x plus 3. So what you're going to do is you're going to take the binomial number, the number connected to the binomial right here, and you're going to do a negative 3 in this little column on the outside. This is what we're dividing the polynomial by. Then you're going to take each of the numerical values here and write them down. So we have a 2, we have a 3, we have a negative 4, and we have a 15. For this first row, we're going to just bring this down, not do anything to it, but here we're going to multiply it by this negative 3. So all it really is just a loop of adding and multiplying. So we're going to multiply this by negative 3. Negative 6 plus 3, negative 3. Negative 3 times negative 3, we get 9. 9 minus 4 is 5. 5 times negative 3 is negative 15. So what you should notice here is this column is the remainder column. We have no remainders if it's 0. If there's a number, then we do have them. And if it's 0, it also means that this right here, the x plus 3 binomial, is a factor of 2x cubed plus 3x squared minus 4x plus 15 of this polynomial. So it is a factor. We can then rewrite this. It can be rewritten as 2x squared. Note how it says squared, it's squared now and not cubed. And also note that we had 4 values from before and now we only have 3. So you're going to be decreasing the degree by 1 when you rewrite it. Negative 3x plus 5. And you don't write out the remainder if it's 0, but you do if it is a number. We'll get to that later. Okay, we can write this then like 2x plus 5 or minus 5 and x plus 1. You can even go a step further and write them out like x is equal to 5 over 2 and x is equal to negative 1. Alright, in this question, for example, if you took out the 6, you'd be able to factor out an x, which would make your question a lot easier. Okay, but let's just stick to this one for now. A thing you should also notice here is we're missing an x to the power of 2. When you're missing something like that, you're going to have to replace it with a 0. You're still going to need the placeholder. Alright, so we have negative 4, we have 1, this is 1, x is not 0, remember it's still a value. And then we have 0 for x minus 2, we have negative 10, and we have 6. Alright, bring down the 1. 1 times negative 4 is equal to negative 4. Negative 4 plus 0, negative 4. Negative 4 times negative 4, 16. 16 plus negative 10 is 6. 6 times negative 24, or 6. And 6 times negative 4 is negative 24. And we're going to get an answer of negative 18. This is our remainder column. So we have a remainder of 18. And we can then rewrite this out, but we have to include our 18. Usually in textbooks you'll see it written like this, negative 18 over the x plus 4. And most teachers will want it done like this. So if you have a remainder, usually write it like that. The factor theorem. Just doing a quick example, we're going to put x to the power of 3 minus 7x squared plus 14x plus 8. So in a question like this, you're probably going to just be told factor. What they mean by that is you have to find your own factors, and it's usually going to be factors for this number here, the one that does not have any x attached to it or any type of exponent. So we have to find factors of 8. For 8, we can do x plus or minus 1, x plus or minus 2, x plus or minus 4, and x plus or minus 8. Don't worry, you're not going to have to test every single one of these points, because nobody wants to test 16 points. That's going to take way too long. So you usually start with, I don't know, you could do divide it by x minus 1, for example. That's usually a pretty good bet, is going in the order that it's laid out. So our question was x to the power of 3 minus 7x squared plus 14x and plus 8. Okay, so let's just test out x minus 1. So we're going to be putting plus 1 right here. 1, negative 7, 14, and 8. Bring down 1. 1 times 1 is 1. At negative 6, when you add them, negative 6 times 1 is going to equal 6. 6 plus 14 is going to equal 20. 20 times 1 is going to equal 20. 20 plus 8 is 28. So this doesn't work. So now we can say that x minus 1 is not a factor of this polynomial. Okay, let's do another one. We're going to try 2x to the third minus 5x squared minus 4x plus 3. Okay, let's go ahead and try x plus 1. Alright, put negative 1 right here. Our numbers, bring down the 2. 2 times negative 1 is negative 2. Negative 5 plus negative 2 is negative 7. Negative 7 times negative 1, 7. Negative 4 plus 7, you're going to get 3. 3 times negative 1, you're getting negative 3. Therefore, we have a remainder of 0, meaning that x plus 1 is a factor of this given polynomial. Okay, let's do a more difficult question for our final example. We're going to be doing x to the power of 4 plus 4x to the third minus 7x squared minus 34x and subtract 24. So it is pretty long. In long questions like this, you're going to first want to see if there's a common factor. If there's a common factor, factor it out. It'll make things so much more easy. And since in this type of question you might just be told to factor, we'd be looking at this number once again. But as you can see, this is a pretty high number. So you should usually start with smaller things, like you should test x plus 1 or x minus 1, just for the sake of easiness and time. So first of all, we're going to be trying, let's go with x plus 1. Alright. Or actually, let's go with x, we'll go with x plus 1, yeah. X plus 1, so we're going to have negative 1 right here. We have 1, 4, negative 7, negative 34. Sorry, this is a 7 if you can't tell. Negative 34 and negative 24. Bring down your 1. 1 times negative 1 is negative 1. Negative 1 plus 4 is 3. 3 times negative 1, negative 3. Negative 3 plus negative 7 is negative 10. Negative 10 times negative 1 is just 10. Negative 24. Negative 24 times negative 1 is just 24. As you can see, since this is negative 24, negative 24 plus 24 is 0. We have no remainder. But what you'll notice is we still have a lot of values. We still have x to the third plus 3x minus 10. Wait, sorry, 3x squared minus 10x minus 24. We still have a bit too many values, so we're going to have to put it through another round of synthetic division, which I'll write up here. Alright, so we already know that x plus 1 is a factor, because it worked when we did it. So we know that this is a factor of our larger polynomial, which means we have to try a different one to get this equation a little bit smaller. Let's try dividing it by, we'll divide it by x minus 3. We'll divide it by x minus 3. So we put it into our synthetic division. We're going to be putting in plus 3, or positive 3 I should say. 1, 3, negative 10, and negative 24. Bring down your 1. 1 times 3 is just 3. 3 plus 3 is 6. 6 times 3 is 18. 18 plus negative 10 is 8. 8 times 3 is going to be 24. As you can see, we have a 0 remainder, meaning that x minus 3 is also a factor of our larger polynomial. We can then go a little bit further and write this out again as x squared plus 6x plus 8. Once you factor it, you're going to get an answer of x plus 2 and x plus 4. Thank you for watching. I hope you enjoyed, or at least got something out of it. I'll likely be making another video following up on this topic fairly shortly, so stick around for that if you're interested. Once again, thanks for watching, and I'll see you later.